Hello everyone, it is January 23rd and today I'm going to be working on LeetCode problem 1488, Avoid Flood in the City. Your country has 10 to the 9th lakes. Initially all the lakes are empty, but when it rains over the nth lake becomes full of water. If it rains over a lake that is full of water, there will be a flood. Your goal is to avoid floods in any lake. Given an integer array rains, where rains of I is greater than 0, means that there will be rains over the rains I index lake. Rains I equals to 0 means there will be no rains this day, and you must choose one lake this day and dry it. Return an array answer where the answer.length equals to rains.length. Answer of I equals to -1 if rains of I is greater than 0. Answer of I is the lake you choose to dry in the ith day if rains of I equals to 0. If there are multiple valid answers, return any of them. If it is possible to avoid the flood, return an empty array. Notice that if you choose to dry a full lake, it becomes empty, but if you choose to dry an empty lake, nothing changes. Okay, and since I have trouble understanding things while I'm reading them, I'm going to reread it once more. Okay, in example 1, we have the rains array. It says after the first full day, the full lakes are 1. After the second day, the full lakes are 1 and 2. After the third and the fourth day, all of the lakes are full. There's no day to dry any lake, and there's no flood in the lake. Example 2. After the first full day, the full lakes are 1. After the second day, the full lakes are 2. After the third day, it's 0, so we choose to dry a lake. So we're going to dry this lake. And then the fourth day is 0, so we can choose to dry another lake. Well, we don't choose to dry, we do dry lake 1, and there are no full lakes. After the 5th day, the full lake is 2, and after the 6th day, the full lake 1 gets full. It is easy that this scenario is flood-free. Okay, after the second day, full lakes are 1 and 2. We have to dry one lake in the third day. After that, it will rain over the lakes 1 and 2. It's easy to prove that no matter which lake you choose to dry on the third day, the other one will flood. I see. So on the third day, we choose to dry either one of these. But on the next day, we have to make lake 1 full. So if we choose to dry lake 1 on the 3rd day, on the 4th day it will be full. So it'll be, the full lakes will be 1 and 2. And then on the 5th day, we have to flood lake 2. Let me reread example 2. So we flood lake 1 on the 1st day, which is valid. Flood lake 2, valid. We dry lake 2, which is why we put a 2. We dry lake 1. But we could have swapped these as well. It could have been 1 and 2 in this order. And then we flood them again because they're available to be flooded. So it looks like we'll have to find potential days that we could flood a lake or dry the lake based off of if in the future we have to flood the lake. So the days where there's an actual number that's not 0, we don't have any choice but to flood it. But it's when we're given the option 0, 0 that we need to, it seems like we need to look ahead of what days will be flooded in the future in order to determine what the best choice is in days to dry, if any choice is available at all. I'm going to copy this over. I'll copy both these over. Okay, say we're iterating through this array. And we'll need a way to check whether or not 1 is available to be flooded. If it is, then I'm just going to say, for now, I'm just going to put an empty array where a 0 indicates that the lake is not flooded yet. And the index is the, is that all right? Let's say a set containing the lakes that are currently flooded. Okay, and we're on index 0. We have to flood lake 1. If the integer 1 is in the set, then it means that the lake has already been flooded. So we're not able to do this in which case we'd return an empty array because it's not possible. And if 1 is not in the set, then we add it to the set, and now lake 1 is considered flooded. If we move along the array, lake 2, is lake 2 in the set? Is it flooded already? It's not, so we can add lake 2. And now we get to the main part of the problem that we need to think about is if we have a 0, how do we decide which lake to flood? And I'm thinking that it would be most logical to remove the lake that is next to be flooded in the array. So I'll say n as in next lake to be flooded. Let me just write that right here actually. N equals next lake to be flooded. Just so we're all on the same page. And that'll be, n will be the first value in the array that is not 0. We can just keep on iterating through, because based off of that, we know, based off of that, we can even see how many zeros are in between these two pointers, allowing us to have more chances of drawing a lake. So 2 is the lake that we need to be dry for the future. So if we have a 0 and we have the next integer that's not a 2, we'll decide to dry lake 2. And then we can move this pointer over and then this pointer over. And then we have another 0. And then since n is past 2, we know we need to dry the next lake, the next integer that is not 0 in the array, starting at n, which denotes the next lake. So we need to dry 1 now, because we have a 0, we have the option to dry. So we remove 1, and then we move this pointer over, and n gets moved over. And now we're at 2, and now this has to be flooded. So we flood 2, and this gets moved over, and now 1 has to be flooded. Okay? And while we're doing that, let me go back a couple steps because I need to update the actual resulting array that we're going to be returning. So since n is already on the lake that needs to be dried, and we're currently at our index, which has a value of 0, then we append the value of 2 for n. So I could even I can make the condition that if the index value that we're on is 0, then we append the value at index n, which is 2. And then if it's not 0, then we need to append the other value. So we've moved this over. And then there is one other thing I'm thinking of. In the case where, is it going to have us dry more lakes than are necessary, more lakes than are necessary? So this implementation I kind of have a good idea on, but let's think of an edge case where we have a 0, for example, and then see, we flood lake 1, we flood lake 2, we can dry lake 1, dry lake 2, and then we have a 0 though. So must we, I don't know why I'm saying must we, like I'm in 17th century Britain, but if there's a 0 there, you must choose 1 lake this day to dry it. So this condition says that we must dry it. Notice that if you choose to dry a full lake, it becomes empty, but if you choose to dry an empty lake, nothing changes. Okay, so that is valid then. So I'm going to have to think about, we don't necessarily return an empty array in that case. In the case where there's more lakes to dry than there are lakes that are flooded, we just have to deal with it within our conditions. So this could get a little interesting. Okay, I want to go through this example one more time. Our initial value is 1. Is 1 in the set? It's not, so we add 1 to the set, and then we append -1 to the output, because reigns of I is greater than 0. Okay? And reigns of I is greater than 0, and we are allowed to flood it. Okay? And we move this index over, we move this index over. We're at 2. Is 2 in the set? Yes, it is. Is it greater than 0? Yes. So we add 2 to the set, and we output -1. Move both of these over. Okay. Is the value at index at 2, is the value at index 2 greater than 0? No, it's not. So we're allowed to free a lake. So then we use a while loop to iterate through from this index to the next available value that is not 0, which should be 2. And then, okay, and then we remove 2 from the set. If it's in the set, great. If it's not, then it won't make a difference. That's interesting. If it's in the set, maybe it will make a difference though. Say it's not in the set then, and we have the option to free an integer, to free a lake. It would be most wise to free a lake. So it's not actually, the condition isn't whether or not the value is in the lake. The value 2 is in the lake. we traverse through the array until we find the first lake that is flooded, the first lake that is in the set. So, because there's a possibility that we never flooded 2, and yet we eventually got to a value of 2, so it's not flooded yet. So how can we dry a lake that's not flooded? It's best to dry a lake if there is a lake. So that's something I need to keep in mind, is that when traversing the array with n, I need to look for the first value in the array that is flooded. So how will I be able to do that though? While reigns of n not in set, while n is less than the length of reigns and reigns of n not in the set. So eventually, it's not the case in this example, but if it was 10021, then it would make most sense to, let me rephrase that. If this was the case where there was only 1 in the set and then we got to 2, given this 0, we're allowed to free a lake, but 2 is not the lake, not free a lake, dry a lake. We're allowed to dry a lake, but 2 is not an option to dry. So it makes the most sense to dry the next available lake to be dried, which is 1, which is why we keep on traversing through the array until n is the value, reigns n is in the set. Okay, I think that was clear enough. Okay. Let me get some water really quickly. Okay, but with that in mind, let me go back a couple more steps, back to where I was before. With this condition in mind, I'm wondering if, since we removed lake 1 from the set, what should we do with the n in that case? In this case right here, that we can dry a lake, but we want to dry the next lake that has already been flooded that we run into. What if, okay, this is interesting. And I don't even know if this will be a case that will be within the test cases, but it's still something that I think it's a big part of the logic of the problem. So we dry lake 1, that's dry. And then we move this over. And then what should n just be reset? Now we can dry another lake, but there isn't another lake to dry. So I suppose if the set is empty, we don't need to traverse n because there's nothing to dry. So then we would continue iterating through. Now 2 is flooded, and then 1 is flooded. We have the option to dry, iterate through with n, we run into 2. So we do dry it. I think I may have to write the code out first and then work on this case second. The case in which no. And then we move this over and we bring n back. Do we need to bring n back? We wouldn't even need to, though. We get to free another lake, so we continue moving n over. Free 1 if it's in there, otherwise keep traversing n. Free the next lake if it's in there, otherwise keep traversing n to the next value greater than 0. I'm going to make a little mental note. Keep traversing index, or keep traversing n if rains n not in set. I mean, that is what I did here, but we don't reset it. We just keep it moving forward. Okay. I think I'm ready to code this then. So we will create a resulting array. 0 times the length of rains. No, I can just make it empty initially. Okay. I'll have 2 pointers called left and right is fine. And we do need to traverse left, this left pointer, all the way to the end of the array. And then we also need to initialize a set containing the lakes that have been flooded. Okay. If rains left is greater than 0, so if this lake needs to be flooded, if rains left is in the flooded lakes, then we return an empty array, which is the case here. We flood lake 1, we flood lake 2, we free either of these lakes. We flood lake 1, say it's dry. Lake 2 is flooded already, so we can't flood it twice. So we return empty array. Okay. If it's not in the flooded lakes, then we need to flood it. And then we append the lake that we flooded. Then we move left over by 1 and right over by 1. Sorry, that's not like that. They both move over by 1. The resulting array right now equals to 1. No, that's not right. We append -1. And the set contains 1. Okay? Now what if rains left equals to 1? Or equals to 0? Now we have the ability to dry a lake. We need to search for the first lake that is in the array after this index that is also in the set. While rains right does not equal to 0, we traverse through the array, right plus equals to 1. Well, it doesn't equal to 0 and rains while right is less than the length of rains, and rains right does not equal to 0, and rains right in the flooded lakes. No, I'm not going to say that. While right is less than length of rains, it's not equal to 0. We need to stop once the value here is in the flooded lakes, if it is. I mean, let me just take another minute to think about this. Okay, and rains right, not in flooded lakes. That's better. Okay, because if it is, then we just keep traversing. Or no, if it's not in, if the value is not in the flooded lakes, we keep traversing until we find the first lake that is. So that's good. And so it is now once we break out of this while loop. And so we remove it from flooded lakes. And then we append the lake that we free. Okay, so where were we at? Okay, we were at 2. So 2 is greater than 0. 2 is not in flooded lakes, so we add 2 to the set, and we append -1. Okay, then we move these both over. Rains left equals to 0, while right is less than the length of the rains, and rains right does not equal to 0. And rains right not in flooded lakes. 2 is in flooded lakes, so we stop traversing. We remove lake 2, we dry lake 2, and we remove it from the set. And then we append it to res. Okay, so the question is, do I reset R back to where L is, or do I keep just keep moving them both forward? So let's say we move them both forward by 1. L equals to 0. Rains left equals to 0, while rains right is less than rains, which it is. Rains right is not 0, yes. Rains right is in flooded lakes, so we remove 1 from the set. We append 1, and we move these both over. So R is outside of the array now. Okay. Let's just keep going with this example for now, and I'm going to come back to that in a minute. 2 is greater than 0. 2 is not in, oh, and 1 has been removed as well. 2 is greater than 0. We add 2 to the set. We append -1. -1. Move both of these over. R is still irrelevant. 1 is greater than 0. 1 is not in the set. We add 1 to the set, and we append -1 to the resulting array. And then now now we've broken out of this loop. There's no more left to iterate through the array, and so we return res. Okay, so I believe that pretty much covers, I'd say 80%, 85% of the problem. There's just a couple of edge cases that I'm thinking where I'm not sure about R resetting it or not. Let me think. We add both of those. And I could be, maybe my solution's correct, but I'm not super set on it yet. No pun intended. Traverse through, get rid of 2. Okay. This moves over by 1. This moves over by 1. Go to 1. We remove that. L. I think we do reset it, because see right here, R is outside of the array, and we do need to flood 2, which has been freed because of these 2 zeros, dry up both of these lakes. But say if we were to reset it back here, and then we start traversing, we do have 0. So it would make sense to dry up lake 2. What if we had 202, for example? So we do reset it. Yeah. Otherwise, if we didn't reset it and we kept traversing through here, this would be outside, R would be outside, so we would never run into this condition. So it needs to be reset. Okay. So right would equal to left plus 1. Now let me redo this condition. So those have all been freed. We flood 2. These both continue. So where would we be at? We'd be at, hypothetically speaking, for the sake of this example, it would be -1, -1, 2, and then 1, and then -1. We flood this We flood 2, so we put -1. And now we're at 0. And then we continue iterating. If there is a lake, I'm not set on it. No. Rain's right, not in flooded lakes. 2 is in the flooded lakes, but we remove that and then we append that. Maybe that is valid though. I think it may be valid. It's either one or the other, obviously, but either this is really breaking a condition, really breaking the answer, or it's really good. Not really good, but it's good. We remove that and we append it. I think it's good. Okay. Well, time to run it. Key error 0. Brains right. Doesn't say anything about being outside of the array, like the right index is out of bounds. Flooded lakes dot remove rains right. Flooded lakes that's spelled correctly dot remove rains right. It's a set. Remove is correct. Rains right, not in flooded lakes. Right plus equals to 1. if you remove something from a set, or excuse me, if you call the remove function on a set and the value is not in the set, you shouldn't get a key error. So what is the problem? Wait a second. If it doesn't equal to 0, this isn't right. Range right does not equal to 0. While it does equal to 0, we need to traverse. And range right not in flooded lakes. We should say or. Well, a little band-aid for the problem. Taking too long. Nope, not gonna do it. Ah. Negative 1, 69, 1, and 1. So if there's nothing to remove, I see. Is that right? $69. So they did a negative 1. They dried 69. And then there's nothing to dry. And you must choose one lake that's staying dry. Return an answer. Answer equals the range length equals to negative 1. Choose to dry on the ith day if rains I. That's interesting. So they're appending a 1 if there's nothing to dry. because 69, the lake 69 was flooded, 0th index, dried the first index, and then there's nothing to dry. But I didn't see that in the problem statement. So if length of flooded lakes equals to 0, res.append 1. Else we flood lake 1, we dry lake 1, we flood lake 2, we dry lake 2. We flooded lake 1 correctly. If length of flooded lakes equals to 0, we didn't do that. Else, while right is less than length of rains and rains of right equals to 0, or rains of right not in flooded lakes. Oh, I think this is the problem right here. We're outside of the scope of, right is outside of the scope of the array. So in this case, right would be index 0, 1, 2, 3, 4. Right would be like 5, and we're not removing anything in that case. So let me remove this and let's see where we're at. That may break other test cases. So this was, let me copy this over as well, just so we know which one we didn't pass. Okay, let's rerun it. Right is less than rains. We are at, we're at an hour already. Dang it. If right is less than rains. Append -1, move both of these over. L equals to 0. While right is less than rains, and rains of right equals to 0, or rains of right not in flooded lakes. Gets moved over, that gets moved over, and that gets moved over. I don't know what to do in this condition. I could maybe free the last index in our output that is -1. No, I wouldn't do that. That wouldn't even make any sense. I'm going to give myself about 3 more minutes because I have to go to the gym soon. So if it's not in the flooded lakes, which one to remove? I could remove any then. Can I just remove any? Okay, I'm just gonna ask ChatGPT for one tip, okay? Okay, pop. Maybe it'll work, maybe not. I know you can't remove the last element added. Well, I mean, more test cases pass, but wait a second. Would I remove the last element added though? I could just store the last element added somewhere else. I could just do that, I suppose. Let's just see. This is bad. This is really bad. Because then I can free it, or I can dry it, and then it wouldn't even be the last element really, because it's already been dried. So that wouldn't even make any sense. That's like it's a Hail Mary. But if it's still in the set, that means that we haven't dried it yet. So actually it's not as bad as I said. Yeah, this is just getting ridiculous. Maybe if I get a... I was gonna say get a stack and then append each lake that we've added to the set to the stack, and then if it's been dried, then yeah. Yeah, see, this is what I was gonna do. But then we're just getting into desperation mode, so I think it's time that I look this up, and then I need to get going. Oh, yeah, let me remove that. I didn't mean to do that. Yeah. Resetting it was not a good idea then. Okay, I need to leave. I will be back to finish this. I need to go to the gym real quick. Okay. Okay, sorry about that. I am back from the gym. Let me look back at what we were doing. Drying must be decided on which lake will rain next soonest. You must dry the lake that will rain next. But what if it's not inside there? On a 0 day, dry the flooded lake that will rain next and soonest. Track when each lake will rain next. They're using a heap. Why would the lake be in the full set? Oh, okay. That's for next iterations. Okay, so if it's not in the full set, we add it. Then we append -1 because we have flooded that lake or filled the lake. Remove the current day from the future list. Pop 0, that would be the first occurrence of that lake getting full. If there is another time when the lake will be rained on, no. If it still exists, if there are still more days where that lake will have rain, then we're pushing I don't really understand this line. I don't think I have the mental capacity to continue thinking about this after the gym. This may be one of the cases where I have to come back to it tomorrow. Okay, we have all the days that this lake is going to be rained on. This would mean that the lake is already full, so we can't fill it. We're popping from the front of the dictionary. I honestly didn't know we could pop from the front like this. Okay, so that's the current day. If there still exists more days, we push today, and what does this refer to? Here we're appending a day. So this refers to a specific the first value. Okay, so is this the priority day, the most prioritized lake? I think this refers to. Let me ask them. And I apologize for this video going on for too long. I would have definitely liked to have gotten closer to the solution, but since I'm not, I may as well try to learn some stuff. The next rain day, okay. The lake with the earliest upcoming rain will always be on top. I see. This is the next day it will rain. Because the dictionary's values contains every day that it will rain for that lake. So by popping off the first day that it will rain, the next day that it will rain needs to be pushed to the heap. So then if we keep doing that, then we keep on appending the days in the lake, and then when we pop off the heap, we're popping off the earliest upcoming rain. So I can kind of see that now. On dry days, we dry the lake with the earliest deadline. I think I understand. Okay, so clearly this was wrong. Let me. Now, I'm pretty much maxed out in mental effort for the day, but I'm going to try to see if I can reason about this. So, there's a few parts to the problem. The first part, each lake will be a key in a dictionary, and the key will be the lake, and the value will be an array of days that it rains. Okay, and then if it is a day that it is not equal to 0, if the day is in a set which contains the rainy days, or it contains if the lake is currently flooded or rained on, day 1, day 2. If the day that we're indexing on is already in the set, then we return an array because it's flooded. If it's not, then we add it to the set and then append a -1 to a resulting array. If the value equals to 0, then we need to choose the next day in the heap, which contains the most prioritized, it contains the earliest day that a lake will be rained on that would result in a flood. So it could be, it is a pair where the first index in the pair is the day, and because a min heap works such that when popping off a value off the heap, it'll return the lowest number. In this case, it'll be the lowest number in the 0th index of the pair, and then the lake that is the first index of the pair is the one that we're drawing. So then we would remove that off the set, and then we would also append that to our resulting array. But where does the dictionary come in? So if day 1 is the most prioritized, then we remove that. But I don't remember. Oh, okay. We append the next value in the dictionary in that lake's array at the 0th index, because that would be the next most prioritized lake in day. So we append the lake, or excuse me, we append the day and the lake as a pair back to the min heap. I'm curious though, I don't remember why how we created the min heap in the first place. Do we just append each initial, or excuse me, we append the first value in each key value pair to the min heap? That wouldn't make sense though, because maybe it would make sense. Just append the initial value for each key value pair to the heap. Because since they're based off of the earliest day, then we would never pop off yeah, I think that makes sense. I don't know if I can explain it well, but maybe I can implement it. I know explaining myself is the important part as well of programming this, but by now, this is, I probably wouldn't have passed the interview, so this is just me trying to implement this and learn the method, and this is pure spite that I have to get the problem right. Okay, so we append the day. We have a resulting array. And then we have a min heap. Import heap queue, I believe. And we want to append so this will be the lake and these are the days. So we want to append days 0, prioritize the earliest day and the lake. And we only want to do it for one for each pair of key values. If the lake is greater than 0, if lake in rained lakes, return the empty array. Else result.append -1. Else if the lake, if it does equal to 0, then we need to remove the earliest, the lake that is rained on the earliest. If we were to remove a lake in the heap right now, it would be 1. But what if 2 comes after right here? Then it would make more sense to remove 2. So I don't understand. This is the day. Min day, min. Next day, next lake. And then we need to pop that. We need to remove it from the lakes. We need to append the lake. We need to pop it from the dictionaries. We need to pop it from the values, the first value in the dictionary with the key of next lake. and then we need to push that lake's, well, if the lake still exists, if there are still more values within the values of this key next to lake, then we need to push the next day to the heap. So we're pushing it to the min heap, and then we are pushing the first value. Well, yeah, pushing the first value. Which would be 0. And then we're also pushing the actual lake. Okay, well, let me look this over once. If this doesn't work, then I'm still gonna post it. It'll just be a little bit of a defeat in my heart, and then I'll have to come back to it tomorrow and try to really learn the solution. So let me just double check it to make sure. The lake we appended the next day. Only for we're appending every day for that lake that it gets rained on. For each key value pair, just append the first day in the values, we're returning an array if the lake is already full, and then returning -1 if it's not, and then if it is now full. Else, if it equals to 0, lake equals to 0, we need to remove the lake that was rained on the earliest. For some reason that doesn't sound right. Popping the first value in the values of next lake. And then if there are still other values, we push back to the min heap the next day of the next lake values, as well as the actual lake. Okay. All we can do is hope for the best. It could be import heap. I don't quite remember. Rained lakes. Oops, rained leaks. That sounds inappropriate. Okay, everybody. I think that is it for me. I don't have the stamina to continue. Let's enter this in. Prioritized by the next rain. Oh, I see. That won't solve the other problem of adding lakes that haven't been rained on yet. Yeah, I see. So we're popping the first element and then for the first value, which is the day. If there are still more, we push the next day that the lake gets rained on. I see. I think I see. So this is not correct. Heap Q equals heap pop. Okay, so we would do it here then. If lake is greater than 0, add the lake, and then pop the first value here. Okay, if 1 is greater than 0, add the lake, pop the next day, which is 2, 4, 0, 1, 2, 3, 4, 5. And then if there's still more days, no, we pop 0 actually. And then if there's still more days, we pop 5. Append -1. Then there's 2. We pop day 1. And then we append the next day, which is 5. And then we get a 0. And then we pop the very next day, which would be 4. And we remove it from the set. Then we pop the next day, which would be 1. I think this is correct now. pop it from the min heap. Popping the next state from the min heap. Then removing the lake. But there wasn't anything to pop. If min heap. I see. Yeah. And then if you can't pop anything, I probably like an hour ago, I said that there was a condition in which if there's nothing to dry, or there was a test case where there was no lakes to dry, but one was still appended, which they didn't really specify in the prompt to just append a 1. So I don't know, for some reason I'm trying to give myself credit for thinking of that. Okay. Well then, that was lengthy. But at least I understand what they're getting at now in terms of prioritizing the next day that the next lake that needs to be dried by prioritizing the min heap based off the days. So, so I'll need to find other problems. Let's see. Usually there's a similar questions tab right here, but there's not. But nonetheless, boy, that was a doozy. So if you made it this far, if you just fast forwarded to this part, you hung in there, because man, that got difficult at times. All right, well, I'm not gonna let this video go on for any longer. Thank you all for joining me. Hope you're having a fantastic night or day and that everything is going well. Take care. One quick note, when I was deciding how I'm going to determine what lake to dry up, an immediate thought of mine should have been, how am I going to prioritize this? Priority queue. So this is something that should have gone on in my mind, but I just wasn't thinking about it. So that's just food for thought. Okay, take care.